Okay, so we went through the first part with like the greatest common factor and how to do that with different variables and stuff. Now we're going into like the true factoring. There are a few different ways to factor, but I always try to do it the easiest way. If y'all want to go hit that light switch, it might take away the glare back there. I don't know if there is a glare on your side. It looks like it on me. It's one of the ones on the end. There are a couple different factoring ways. I'm going to do it the easiest way. But one of the ways, and if you learned it a different way or something like that, you're welcome to do that. I'll show you two different ways. I try not to show you a bunch of different ways, but on this one, I may show you two different ways, and then I'll start doing it one way just to get in the habit of doing that. But, this one right here. So first thing we got to do is when we get to the test and all the problems are mixed together and all that is the different types of factoring that they are. And we may, at the end of this, kind of write out a little scenario here. But if you have four terms, this is four terms, right? 1, 2, 3, 4. The only way to do this is factor by grouping. So what factor by grouping is I'm going to group the first two terms together and group the second two terms together. So the blue one, now I'm going to pull out my greatest common factor like we were doing the other day. Remember, it's the smallest exponent. So I can take out an x squared from both of these. When I take out an x squared from just the blue ones, I'm left with 1x here, and I'm left with a 2 here, okay? So remember, you can always like think about distributing it back through. X squared times x would be x cubed. X squared times 2 would be 2x squared. On the next one, I'm going to pull out what's common on this one. And what I want to pull out on this one is, I hate to start with this one, but that's fine. I'm going to pull out a -3 because I can divide -3 and -6 both by -3. So if I take away -3 from that, it's just x, and then -6 divided by -3 is +2. If you do this correctly, this and this will be the same. Okay, so that's how you know you did it correctly. If we were accidentally to pull out a positive, it wouldn't be exactly the same. So that's how you know you did it correctly. And then we kind of finish with this on Monday. Whatever's on the outside comes together as 1, and whatever's on the inside comes together as 1. What you're technically doing is factoring out x plus 2, but that's the way I think about it, is the outside come together and the inside come together. Okay? So factor by grouping, you group them, and then you factor each group in there. And you will have to use factor by grouping when you have 4 terms. So if I do another one, what you want to do, and it doesn't really matter what order, it'll always work, is group the first two and then group the second two. I mean, you always want to group the first two and the second two together. So in my blue one, again, I can factor out an x squared. So I'm left with 2x. If I have 2x's and I take away 2x's, I still have to put a -1 right there. Because think about if you distribute it back through. X squared times 2x would be 2x cubed. X squared times -1 would be -x squared. So you do want to make sure that you put a 1 there, okay? And then just looking at the red one, all I'm doing is looking at that. I'm not really paying attention to this yet. Kind of gives you a hint. But 4 and 2, I can factor out a 2. So that becomes 2x minus 1. And again, if you did it correctly, those will be the same. So I bring together what's on the outside, x squared plus 2, and then bring together what's on the inside, 2x minus 1. All right, more factor by grouping. Again, the idea here, and we'll probably write this out at the end, is sorry, I seen what was different about this one. Actually, we'll make it both. All right, so I grouped the first two together and grouped the last two together. But you use factor by grouping when you have 4 terms. So in my blue one, what's common is x squared. I pull out 2 of those x's, so I have 1 left. 3x squared. I pull out 2 of the x's, so it's just 3 left. In my red one, if I were just to pull out a 4, I just want to show you this. If I pull out a positive 4, I'd have -x minus 3. This is not the same as this, but it looks pretty close. So what if we just pulled out a -4 instead? Negative 4 divided by negative 4 would be 1. 12 divided by negative 4 would be negative 3. And now these are the same, so they'll come together. And then the stuff on the outside comes together. Ooh, technically you could probably factor that a little bit more, but we're not talking about that yet. So I'm going to come back to that one if I remember to, because there is one more factoring step you can do, but we're not there yet. All right, one more of these. Oh, no, we got some more factor by grouping down there. So again, 4 terms. I group the first 2 together. I group the second 2 together. Haven't really done one like this, though. On this one, you have 3 and 6, so I could pull out a 3x squared. So if I pull out a 3x squared from this, I'm left with 1x. If I pull out a 3x squared from this, I'm left with 2. 2 times 3 would be 6. And then the red one, they look pretty similar right now, but I got those negatives. So I'm going to pull out a negative 1. If I take away a negative 1, this becomes positive x and positive 2. So now, you know you did it right because those are the same. Put those together, and then put the stuff on the outside together. There is one more factor by grouping topic. Okay, so if you have x's and y's in here, you still are going to work the same way. When you see 4 terms, think factor by grouping. So I group the first 2. I group the second 2. So my blue one, I can pull out an x, so I get y plus 2. And again, think about distributing it back through. X times y would be xy. X times 2 would be 2x. In my red one, I have negative 3 and negative 6. So what if I pulled out a negative 3? That'd become positive y and positive 2. Okay. So you group them together. Let me go ahead and say this. Put those together, the y plus 2 together, and then put the stuff on the outside together. And by the way, I hadn't said this yet. You can always, we did this the other day, FOIL back out to check your answer. Okay, you can always FOIL it back out to check your answer if you want to. So what factoring is actually the opposite of foiling, and we'll talk about that on the next problem for sure. But you can't always FOIL these back out to check your answer. All right. So that is if you have 4 terms. What if you have 3 terms? If you have 3 terms, factoring is the opposite of foiling. So my answer is going to look like a FOIL problem. I'm going to have 2 binomials like this, okay? It's going to look like this. Think about first, outer, inner, last. The first thing I do is always x times x, okay? X times x is x squared. All right, so that's the setup of these. What we're going to do from here is, and it kind of says it right there in the directions, what multiplies to be 6, what multiplies to be 6, what multiplies to be the last number, and adds up to be the middle. You seen this before? Yeah, there are a couple different methods to do this. Yeah. We'll jump into some hard ones, and I'll show you some different tips and tricks, but there are some different things here. So I do this little visual representation to do this, and I say, okay, what multiplies to be 6 and adds up to be 5? This is just a visual thing. You do not have to do this, but you always say what multiplies to be the last number and adds up to be the middle number. On this problem, it's going to be what multiplies to be 6 and adds up to be 5. It would be 2 and 3, right? 2 times 3 is 6. 2 plus 3 is 5. So I write plus 2 and I write plus 3. Those are the 2 numbers that multiply to be 6 and add up to be 5. And that's it, okay? You could FOIL it back out to check your answer. So factoring is the inverse of foiling, but that is all we have to do to get our answer. And we will do a ton of this, I'm guessing, in the next coming topics. And we'll pull up some hard ones too and make sure if we get hard numbers. So on this one, again, they're always going to have this format. X times x is x squared. So on this one, we're looking at what multiplies to be 12 and adds up to be negative 7. If you get stuck, just like you get stuck on factoring, 12 is not that hard, but we can do it on bigger number 2. Go to your calculator. 12 divided by 1 is 12. 12 divided by 2 is 6. 12 divided by 3 is 4. 12 divided by 4 is right there, right? So 12 divided by 5 doesn't work. Actually, as soon as you get back to where you were here, like 3, the next number is 4, you don't have to keep going. So you kind of can make the list of the factors and say, okay, which of those numbers like add up or subtract to be negative 7? So this one would be 3 and 4, right? But it's negative 7 and positive 12. Well, what if I do negative 3 times negative 4? Negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 is negative 7. So it's negative 3 and negative 4. X minus 3 and x minus 4. What multiplies to be the last number and adds up to be the middle number? Oh, it's jumping right into a hard one. All right, if it has like an x squared and a y squared, you can do the same thing. Actually, I'm going to do it. I'll tell you the way that I think about it. The way that I think about it is when you have 3 terms, really when you have an x squared and an x, your mind should automatically go to factoring. If you have an x squared and an x and a problem, you should automatically go to factoring. But look, I have x squared and x coming from the left side, right? Well, x times x is x squared. Well, what about this? I have y squared and y coming from the right side. Well, isn't y times y squared? Okay, that's kind of the way that I think about it. It's coming from the left as our x's, coming from the right as our y. So you put x on the left, y on the right. And then go through your process. Okay, what multiplies to be negative 6 and adds up to be, there's a 1 right here, right? A 1. So this is going to be some different signs. So I'm going to have what? Positive 3 and negative 2. 3 times negative 2 would be negative 6. 3 plus negative 2 would be positive 1. So always kind of check it like that. And then I can write my answer. X plus 3y times x minus 2y would FOIL out to be this right here. I will say the other way, if like the x is coming from the left and the y is coming to the right, there is another way to think about this. The other way you can kind of think about it is, okay, we're always writing x times x, or this one, a times a equals a squared. Sorry. Well, this one, how do we multiply to be negative 3b squared and add up to be negative 2b? You can think about it like this. I'd rather just put a b on the right side, but so this would be negative 3b plus 1b. Negative 3 plus 1 would be negative 2. Negative 3 times 1 would be negative 3. So you can do it like that. That's just not my favorite. I'd rather just say, okay, I have a b squared coming from the right, so I'm going to write b and b on the right. All right, one of the first things you want to do when you get into factoring, just to make the numbers easier, is you always want to check for a GCF. Because if you can divide everything by something, that makes it smaller to work with. It makes your answer better. So I see 2, 4, and 6 right here. If I'm going to divide these all by 2, 2x minus 3, now I have a lot smaller numbers to work with, and I can say, okay, now let's set up my factoring problem. X times x is x squared. What multiplies to be negative 3 and adds up to be 2? So this would be positive 3 and negative 1. So 3 times negative 1 is negative 3. 3 minus 1 would be 2. You do need to write that 2 in front because it is part of your problem. Let's change this number to make it a little harder here. I think we can do that. I think that'll work. Feel like we've been doing some smaller numbers, but so again, when I see 3, 3, and 72, maybe I'm thinking about, okay, I can divide these all by 3 and get x squared minus 1x plus 24. So now I'm going to say, okay, let's go through my factoring steps. What multiplies to be 24 and adds up to be -1? Oh, I did that wrong. Man. Can we change this to a 6? Sorry. I was doing 72 in my head instead of doing... So if we change that to a 6, there's a 2 right here. This is what happens when you make up factoring problems on the fly. Oh, no, that's not going to work either. All we got to do is change this to a minus, then it'll work. My bad. Should have stuck with the easy ones. I was trying to make it a little, so we have different numbers. Okay, my bad. Now, x squared minus 2x minus 24. So what multiplies to be 24 and adds up to be -2? We know x times x is x squared. It would be -6 times +4. -6 times 4 would be -24. And -6 plus 4 would be -2. So -6 times 4 would be -24. -6 plus 4 would be -2. Okay. Okay. So here, 2x squared plus 7x plus 3. So the first thing we always do is check for a GCF. There is no GCF. 2, 7, and 3, I cannot, there's nothing I can divide all them by. So here are the hard factoring problems. When you have a number in front of x squared, a 2, a 3, a 4, a 5, something like that, it does make it a lot harder. There's a couple different ways to do it. I'm going to show you my way first because my way is easier. I don't even want to show you the other one. Maybe I'll do that on the next one, but let's do my way first. Okay, so since there is a number in front of x squared, like previously we always just jumped right into this, right? I want to keep that same pattern so you always know what to do. So we see an x squared and an x, we think factoring. What I'm going to do here is since you have this 2 out in front, I'm going to take 2 times 3. I'm going to take 2 times 3. So I'm going to say what multiplies to be 6 and adds up to be 7. And I do this a little differently than anybody probably showed you before, but it just makes it a lot easier. All right, what multiplies to be 6 and adds up to be 7? It would be 6 and 1. 6 and 1. 6 times 1 is 6. 6 plus 1 is 7. Okay, here's where things are a little bit different. Since I have that 2 out in front and I multiplied by 2 to find my numbers, I'm going to write 2x at the beginning of both of these. This is the part that you forget when you go to do it on your own. I'm going to write 2x at the beginning of both of them. This isn't correct because 2x times 2x is 4x squared, but just bear with me for a second. So now I'm going to write my plus 6 and my plus 1 for the two numbers I came up with. And again, we're not right. Yeah? Is there a next step? Yeah? Yeah, divide. So I look at these 2 and 6. I can divide both of them by 2, right? So I'm going to do x plus 3. Here, 2 and 1, I can't divide them by anything, so I just rewrite it. And now that's my answer. The way that I think about this is we multiply by 2 at the beginning to make this numbers easier to find. Then we divide by 2 at the beginning or at the end to make us back where we were. So we multiply by 2, so we're kind of working up here to make it easier, and then we divide by 2 to put it back to where we were. So those numbers always match up. Whatever you multiply at the beginning will be the same thing as what you divide by at the end. Okay. So here, 3x squared minus 5x minus 2. Again, I am always like to start the same pattern. So 3x and 3x. I put a 3x at the beginning of both of those because I want because I'm going to multiply by 3 to start. So I do 3 times negative 2. So I say, okay, what multiplies to be negative 6 and adds up to be my middle number, negative 5? This would be negative 6 and positive 1. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. So I write negative 6 and plus 1. Do not, I'm telling you right now, when you go to do this on your own, you always forget to write this number in both spots. You got to write it in both spots on these. 3 and 6, I can divide both by 3, so I get x minus 2. 3 and 1, I can't divide by anything, so I get 3x plus 1. Just trying to get Alex to generate a new problem for me. Because I do want to do one more of these. If it doesn't do it this time, I'll just make one up. All right, I want to do one more of these. You got to give me a second. Don't look at my answer here. All right, let's do 8x squared plus 14x minus 15. We got some big numbers here, but that's okay. We can work it out. All right. So on this one, let's do one more of these. First thing I want to do is I know that when I do this, it's going to be 8x and 8x right here. Okay. So now I do 8 times negative 15. 8 times negative 15 is a big number. What is it, like 120? Negative 120. So what multiplies to be negative 120 and adds up to be 14? You can sit here and think about it for a long time, but just go to your calculator. 120 divided by 1. Write all the factors. 120 divided by 2. 120 divided by 3. 120 divided by 4. 120 divided by 5 is 24. 120 divided by 6 is 20. 120 divided by 7. Does anybody see it yet? 120 divided by 8 is 15. 120 divided by 9 doesn't work. 120 divided by 10 is 12. I think it's right here, right? What if I did positive 20 and negative 6? Okay. So if you get stuck, just start writing the factors. Divided by 1, divided by 2, divided by 3, and just keep going until you find it. 20 times negative 6 is negative 120. 20 minus 6 is 14. So I'm going to write plus 20 and minus 6 right here. So then I come over here, and 8 divided by 20, or I'm sorry, 8 and 20 can both be divided by 4. And 8 and 6 can both be divided by 2. Okay, I told you previously that these numbers always match up. I multiplied by 3 at the beginning, and I divided by 3 at the end. Well, in this one, I multiplied by 8 at the beginning, so I divided by 4 and 2, which is 8. So they will always match up. All right, I will show you I will show you this way of doing it. This is the same type of problem. Factor by grouping. I'll put right here alternate method. Okay, if you want to do factor by grouping and you like that, that's fine. I just think it's a little bit longer. So this one starts the same way as what we've been doing. You're going to do 6 times negative 10. So what multiplies to be negative 60 and adds up to be 11? This is a hard one, kind of. It is 15 and negative 4. Negative 4 plus 15 is plus 11, and 15 times negative 4 is negative 60. Okay, so factor by grouping, we need 4 terms, right? So what they do is they split this 11x into the 2 terms we just came up with. So instead of writing 11x, we're going to write 15x minus 4x, which is the same thing as 11x. So they split that into 2 terms, and then they go through our factor by grouping steps and say, okay, my green one right here, my green one, I can pull out a 3x. So I have 2x plus 5. And in my red one, I could pull out a negative 2. So I have 2x plus 5. And then you can put these together and those together. Okay. I do not care which way you do it. If you like the factor by grouping method, that is fine. But that's the way the factor by grouping works. All right. I will probably continue to do it the way that I do it just because I think it's a little bit faster. If like the majority of you really want me to do factor by grouping, I can. Okay, so we already ran into one like this and when we were just doing no number in front of x. But if there's a number in front of x and y, I'm going to write 2x. At the beginning of both of these, the y's are on the right, so I'm going to write y on my right. That's the way that I think about these, with the y squared and the y coming from the right. And then I go through my factoring steps. 2 times 3 is 6. And they really like to use 6 on this. 2 times 3 is 6. So what multiplies to be 6 and adds up to be 5? 2 and 3. So plus 3 and plus 2. Don't forget, 2 and 3 I can't divide. 2 and 3 I can't divide by anything, but 2 and 2 I can divide by 2. Okay. So here we multiplied by 2 at the beginning and divided by 2 at the end. If you ever have a negative in the front, you want to get rid of the negative. The way I do that is divide everything by negative 1. So I have negative 1 x squared minus 4x plus 3. It changes the sign of all those. And then I can just go through my factoring steps. Okay, what multiplies to be 3? And adds up to be negative 4. That'd be negative 3 and negative 1. So you never want to have to factor a negative. So multiply everything by negative 1 or divide everything by negative 1. You technically would have to put this negative out in front. You probably wouldn't write a negative 1. You just put a negative like that because you did change the problem. But get rid of that negative so you never factor by a negative. Aren't there like 30 topics? I got to get going, don't I? Oops. I think 2x squared. I don't remember ever seeing this topic on Alex. I was going to check it real quick. Not hard, but what's it called? Factoring a product of a quadratic. Just making sure that, no, it did not give me what I wanted here. I didn't think that's the way it looked. Okay. Did not think that looked familiar. All right, so this matches what Alex looks like more. This is 6x to the fourth. Always, you're not going to have something super hard like this factoring. Check for a GCF. Can't I divide all of this by 3x to the fourth? So that leaves me with, if I take away 4 of those x's, I have x squared. Negative 6 divided by 3 would be negative 2. If I take away 4 of those x's, I have 1 left. 21 divided by 3 would be 7. I take away 4 of those x's, there's none left. Now it looks like a very easy factoring problem. So always check for the GCF. That makes it easier to work with. So now I'm looking at we can go ahead and do this. What multiplies to be 7 and adds up to be negative 2? Well, the only thing that multiplies to be 7 is 1 and 7, right? So that does not add up to be negative 2. So this one does not factor anymore. That's your answer. You cannot factor that anymore. But I did factor out that 3x to the fourth, so that I do have to write that as my answer. Okay. That one probably will be pretty quick in your assignment. All right. The next part is going to talk about some special factoring. Again, I try not to teach shortcuts when I don't think they're really shortcuts. A perfect square is something that I know we haven't really talked about square roots that much really yet.
I like perfect squares.
A perfect square is defined by like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. But the square root, I know we haven't talked about it, but the square root is what number 2 times itself is that, right? So what's the square root of 16? 4, right? Okay. If you see a perfect square, the majority of the time it is going to be like they call it special factoring. Let's write this out. I'm not going to do the shortcut way first, and then I'll show you a shortcut at the end. Y'all are going to get good at these ones right here. So you say what multiplies to be 16 and adds up to be negative 8. And it would be negative 4, right? So x times x is x squared. And then negative 4 times negative 16 is, negative 4 times negative 4 is positive 16. Negative 4 plus negative 4 is negative 8. That doesn't take that long for y'all to do. So like the shortcut isn't really super helpful here. What the shortcut says, or another way to write this, x minus 4 times x minus 4, those are the same thing, right? So I could write it like this, and I would say x minus or plus something squared would be my answer here. The way you always figure out what it is, I guess you could do it this way, but it's whatever the square root of this is. It's 4. The square root of 16 is 4. And then you look at this sign right here. It would be minus. Like that's the shortcut way, but honestly, these problems don't really take that long just to factor them. So like this one right here, just to do the shortcut method, I could say, okay, 3 times 3 is 9, and 3 plus 3 is 6. And since this sign is positive, I write a positive right here. I know that's a little faster than the other way, but it doesn't take that long just to say, okay, what multiplies to be 9 and adds up to be 6? And you can write this either way. So if you get a bigger number, like this, if you have a number out in front, if those are both, if it begins and ends with a perfect square, right? What's the square root of 4?
2.
So if I write 2x here, to be 2x times 2x would be 4x squared, right? The square root of 9 is 3. The sign in the middle is a plus, so I can do plus. Again, if you get stuck, just go through the factoring steps. Do 4 times 9, what multiplies to be 36 and adds up to be 12. On this one, 9x squared minus 30x plus 25. So you see perfect squares at the beginning, 9 and 25. 3x times 3x is 9x squared, right? 5 times 5 is 25. Sign's a minus in the middle, so I do a minus right here. But if you get stuck, 9 times 25 is 225. What multiplies to 225 and adds up to be 30. I know those are big numbers, but it doesn't take that long. This one is the same thing, but with an extra variable. So you see 4 above here, that's a perfect square. So you can try it. A times A is A squared. 2 times 2 is 4. B times B is B squared. And I put my minus right there. But I'm telling you, you do not have to learn these special products. You can just factor them all out. Now this one is a special one. This is called the difference of squares. And you do kind of got to know this one. So we have done factoring with 4 terms. You got to do factoring with grouping. Factoring with 3 terms, you have to do the factoring like the steps, okay? If you're factoring with 2 terms, you just got to know it's something a little different. Again, you see the perfect square here, which is 16. This is called the difference of squares. And what happens here is x times x is x squared. 4 times 4 is 16. There is no middle term because they cancel out. 4 or positive 4 plus negative 4 would be 0. Okay? So that is what you're actually finding here is what multiplies to be negative 16 and adds up to be 0 because there's missing that middle term. But this is called the difference of squares, and they will always have this format, okay? It only works if there's a minus in the middle. Like if it was plus right here, you could not do this. It has to be a minus 25 or minus a perfect square. So on this one, y times y is y squared. 5 times 5 is 25. And since there's only 2 terms, I do a plus and a minus. What if we had a little bit bigger numbers to work with? Again, if you see that it begins and ends in a perfect square, which means you can do the square root real fast in your head, it's always going to be something special like this, okay? 25x squared, well, couldn't I just do 5x and 5x? 5x times 5x is 25x squared. 6 times 6 is 36. There's only 2 terms, so I do a plus and a minus. What if we add some variables in there? Three a times 3a is 9a squared. 4b times 4b is 16b squared, plus and a minus. I need to do this one up here because this one always messes with people. I'll move that over there so you can see it. These don't have a number out in front, right? But they are still perfect squares. X times x is x squared. Y times y is y squared. And then I do a plus and a minus. That one still works out. Technically, there is a perfect square in the middle, 1, right? 1 times 1 is 1. All right, what if you run across a 2-term problem? A 2-term problem that's not perfect squares, right? There's nothing that multiplies to be 20, or not. There's nothing 2 times itself that multiplies to be 20. So what if I do this? Well, what's the number 1 step of all factoring? Check for the GCF. Couldn't I pull out a 5 and 2 x's from both of these? This is why I went over the GCF on Monday so that we were ready for this. So if I pull out a 5x squared, then I'm left with x squared minus 4. So I have 5x squared, x times x is x squared, 2 times 2 is 4, and a plus and a minus. So you always, we're going to write out the steps of the factoring in just a second when I get towards the end. But the number one step is always check for GCF, because that's always going to make your life easier. Even if it just makes the number smaller, you're always going to check for the GCF. All right, I do have to go back here just because I thought of this now. Now, one factoring by grouping problem. I got to do it. My math brain's not going to handle it. This one right here. See the x squared minus 4? Technically, you could factor that down to plus 2 minus 2, right? Because x times x is x squared. 2 times negative 2 is 4. Okay, if you go back and look at notes. That was just AI giving me a bad problem to work with there. All right, the last kind of step here in factoring world is what if you have an equation to work with? This is called the zero product property. Okay. If we have an equation to work with, we set it equal to 0. We set it equal to 0. And then you get your factoring steps, and you have this right here. The zero product property says, if this is 0, if my answer right here is 0, 0 times anything is what? 0, right? Or if this one's 0, anything times 0 would also be 0, right? So what that says is that either one of these could be 0. So I have x minus 3 equals 0 and x plus 2 equals 0. I set up two equations where they're both equal to 0. And then I just add 3 to both of these and subtract 2 to both of these. So I have two different answers. If I plugged in a 3 or a negative 2, I would get 0 for my answer. So if I was solving this equation right here, honestly, this question right here, I'll ask it in college algebra, and it's like one of my most missed questions. Number one step, GCF, right? What if I divide everything on both sides by 3x? Oh, wait. Let's factor it out. I'd have 3x, and then I'd have x minus 3. I can't do anything else. I can't factor it at all, right? But there are still two x's in this problem. So I need to set 3x equals 0 and x minus 3 equals 0. I need to set both of those equal to 0. It is so common to forget to factor or put the, you just do this part and not this one. So here you divide by 3, x equals 0. Here you add 3, x equals 3. When you have x squared, remember we talked about degree the other day, that means you can have up to 2 answers. So 0 is an answer and 3 is an answer. Almost done, not too far from it. I know this one's longer. But factoring is something that is super important because you use it a lot. On this problem, we have the plus 0 or the equal 0. We haven't done that yet, but it's still the same idea. We say what multiplies to be 10 and adds up to be 7. So x times x is x squared. It'd be what, 5 and 2? 5 times 2 is 10. 5 plus 2 is 7. So plus 5 plus 2. So So that's where we usually were stopping before, but now we have to say, okay, x plus 5 is 0, x plus 2 is 0, subtract 5 from both sides, subtract 2 from both sides. Oh, man. Okay, so if I have a problem like this, we're going to write these steps out in just a second, I think. That's probably how we'll end. But the number one step when you have an equation, as soon as you identify x squared and x, you're thinking it's a factoring problem. If the problem has an x squared and an x in it, you're thinking factoring. So on this one, I want to set it equal to 0. So I'm going to add 8 to both sides so that it is set equal to 0. 3x squared minus 2x plus 8 equals 0. Now I go through, well, you check for GCF. 3, 10, and 8 don't have one. So go through your factoring steps. 3 times 8. What multiplies to be 24 and adds up to be negative 10. Remember, at the beginning of this, we are going to write 3x and 3x. So what multiplies to be 24 and adds up to be negative 10? You got negative 6 and negative 4. Negative 6 times negative 4 is positive 24. Negative 6 plus negative 4 is negative 10. 3 and 6, we can divide both by 3. 3 and 4, we can't divide by anything. So that is where we previously stopped. But now we can say x minus 2 equals 0. 3x minus 4 equals 0 and solve both of these. So add 2 to both sides. And on this one, we add 4 to both sides. And then divide both sides by 3. So my two answers are 2 and 4/3. All right, the last two topics here are Pythagorean theorem. Not really for sure how they got put in here. I'm guessing it has something to do with the next. Okay, so Pythagorean theorem, a squared plus b squared equals c squared. Remember, a is my leg and b is my leg. C is called my hypotenuse. You always want to identify your hypotenuse first. Your hypotenuse is always directly across from the 90-degree angle. This only works in right triangles, which is a 90-degree triangle. It is directly across. This is always my hypotenuse. You always want to identify that. It doesn't matter if you switch up the legs, like this could be A and this could be B, or this could be B and this could be A. It does not matter. But you have to get the hypotenuse on that other side of the equal sign by itself. So that's the one where you want to know. All right. So in this problem right here, it says the legs are 3 centimeters and 4 centimeters. Use the Pythagorean theorem to find the hypotenuse. So I do 4 squared plus 3 squared, find c squared. So that would be 16 plus 9 equals c squared. 25 equals c squared. I guess we haven't really talked about that yet. Like, we need to go into square roots, but to get rid of the squared and get the c by itself, no, this is the right spot to talk about it. To get the c by itself, you do the square root. So c equals 5. So the square root and the square cancel each other out. Y'all have seen the Pythagorean theorem before, right? Mm-hmm. Okay. We'll go to the hard problem then. All right, a word problem with Pythagorean. A ladder is 10 feet long. Draw me a little picture here. I know it's a great picture. A ladder is 10 feet long. It reaches 8 feet up the wall. How far is the base from the wall? Okay, which one is my hypotenuse? 10. Okay. 10 is my hypotenuse. The hypotenuse is always the longest one, but you know it's the hypotenuse because it is opposite of my 90-degree angle. All right, so I'm trying to figure out one of my legs. My other leg is 8, and my hypotenuse is 10. That's why you got to know where the hypotenuse is, because it's always over there by itself. So then a squared plus 64 equals 100. Subtract 64 from both sides, and a squared equals 36. And now you do the square root of both sides, and a equals 6. Okay, I know that I've been talking for like an hour, but I would like to write out, I probably have this somewhere, I probably should just find it. I would like to write out the factoring steps. Okay. Because when you mix these all together on the test, that's the hard part. Next week, we're going to do a bunch of factoring too. So like this is something you need to know how to do. Okay. So the first step is, how do you know when to factor? When to use. When you see, I'm going to write that. I'll say, use when you see an x squared and an x. Definitely use it then. I'm going to say this. We didn't do a lot of these, but or just an x squared. So like those one problems we did where they had just an x squared, okay? But you definitely do it when it has an x squared and an x, okay? All right, so that's how we identify what a factoring problem looks like, okay? Now the steps are you set equal to 0. That's always the first thing you do. You set it equal to 0 by getting everything on one side. Number 2, check for GCF. That's like get everything on one side, then you check for GCF, and then you have 3 options. Okay, if it is 2 terms, it's going to be like x squared minus 16. All right, we'll do a different number because we did 16 a lot. It's going to look like this, x plus 9, x minus 9. So it's going to be, they call it the difference of squares. Sometimes it's better just to write an example out on this. If it's 3 terms, you kind of have 2 different options. And I think I'd rather just put an example here. They call these a equals 1 and a greater than 1. If I had x squared minus 5x minus 14, I factor like this, right? I do x minus 7, x plus 2. If I have a number out in front, get one so I don't mess something up here. Four x squared minus 21x minus 18. On this one, Man, of course I gave myself a hard one. On this one, you have the number out in front. So you always multiply first. 4 times negative 18 would be negative 72. What multiplies to be negative 72 and adds up to be negative 21? That would be negative 24 and positive 3. So you have 4x and 4x. Minus 24 plus 3. Divide that one by 4. X minus 6. 4x plus 3. Okay, so I know I'm just kind of doing extra examples here, but the 3 terms is a hard one because you got to do all the factoring. The 4 terms, you do factor by grouping, like we did at the beginning, okay? So these are kind of like my quick little steps to factoring. I know it's not perfect steps because they're examples, but as soon as you see an x squared and x, your mind goes to factoring. You always set it equal to 0 by putting everything on one side. If there's 2 terms, it's going to be one of those special factorings. If you're looking for like perfect squares, 3 terms, you got to go through the main factoring steps. 4 terms, you got to do factor by grouping. So this like thought process will really help you on the test when all these problems are mixed together. Because on Alex, it's going to, like as you're working on individual problems, it's going to tell you what to do. But when we mix them all together, just... yeah, I mean, I said all these things a million times today. Set it equal to 0, find the GCF. Like, those are the 2 big first ones. And then your brain starts going to the factoring steps.